Hi all, sorry for the delay to start. I have some problems in the laptop with the web application file we should use to the demonstration. Well, who am I? My name is Wendel. I work in information technology more than 10 years. I work for a company in Brazil called Security Labs. We work for a credit card company, government, and the other big companies in Brazil. I'm affiliated to Hackaholic, which is an international group of security research. I had been working with penetration testing the last 3 years. I had discovered some vulnerabilities in webmails like Open Webmail, WebMeow, and the others, access points like the link, Citrix Metaframe, and the other softwares. I wrote some tools that was used in some magazines famous around the world, like Hacking9 and the PC World. I also spoke to some conferences very famous in Brazil, like Hackers to Hackers Conference, Code Breakers, and was invited to speak to others, like IT Underground in Italy and the IT1 Take One Mexico. Well, I am from Brazil. The slide speak by itself. Yes, when I arrived here, everybody speak to me about Brazil. Oh, are you from Brazil? Soccer, what do you think about the next games? All this stuff. So, yes, I'm from Brazil, the city of Pelé, and the slides again speak by itself. Well, what you see in this presentation? What is the WAF we are speaking about? Type of operations, common topology, passive and reactive mode, tricks to detect WAF systems, tricks to fingerprint WAF systems, generic evasion techniques, specific techniques to evade the WAF systems, and what they fail to protect. Well, we have a small description retrieved from the Web Application Security Consortium glossary that basically say that web application firewalls are a kind of firewall specific to layer 7 applications, in the case to the web application, that try to protect the application from hostility attacks in this specific layer. Well, they are also called deep packet inspection firewalls because they look every request and they are able to look response, looking for problems in HTTP, HTTPS, SOAP, XML, services, web services, and the others. Some web application firewalls look to signatory attacks, like you see in many firewalls, and they also abnormal contents, behavior problems, that basically are the same we see in EDS and EPS technology. The web application firewalls can be either software, hardware, or appliance. And basically, they try to protect a web server. Well, some notes about the definition. Some new web application firewalls can work both with attack signatories and the abnormal behavior. Some systems not necessarily need to be in front of a web server, as where in most places we custom to see. They can be directly put in the machine where the web server is running. There is not only, as described in some older documentations that are really used as reference, able to detect only attacks in the incoming packets. It's able to detect attacks in inbound and the outbound packets. Basically, there are 3 types of operation modes. They are negative modes that are based in a kind of blacklist. They are positive modes, which are a kind of whitelist based, and mixed mode. That's what most famous web application in nowadays using. A kind of negative mode and a kind of positive mode. Well, Negative security model recognizes attack by relaying a database of expected attack signatures, like most of the EDS and EPS that we have today on the market. For example, look for any page or any argument with the user input match any potential cross-site scripting strings. This can be, for example, strings, string.from char code, and a combination of all these strings. Well, the good point of this kind of operation mode is that it's very fast to install and use. Basically, you have a pre-built group of rules that try to detect the most common attacks. So you basically get an appliance or a software, install, and this is running. The bad point is it's so generic, so in general you have a high number of false positives, more time to process, and also a small number protection. Positive security model also. Basically, it's a kind of enforcement of the application logic. For example, if you have a script called the news.jsp and it have a field called the ID of identification that only accept numbers from number 0 to number 10 and always starting from number 0 and going to 65535, basically they construct a kind of rule that only allow this kind of data, this kind of digit, start from this number to this number, and all other data will be exceptions and not be processed. Well, by the nature of the rule, that's much more small and it's much more fast and have better performance, and they also provide less false positives when you have good rules. The bads are, it takes much more time to implement. Some web application firewalls in the market provide some tools to automatically generate this kind of rules, what they call in general automatic learning mode or similar name. This kind of stuff is good and they are helping a lot in generate these rules. The big problem is that this rule is never perfect, and to work automatically, they need basic to have human reviews. Else, they will also be so leaky in a fashion that doesn't generate a lot of false positives. And it make the attacker's life much more easy. Well, the mixed mode is basically the use of positive and negative models together, which is happening most of the today's web application firewall. However, in general, all have one that is predominant, negative or positive model. Well, in general, WAF systems can be used in 3 different network topologies between a web server and a web client. This is the most common that we see in the internet, also which people call like a reverse proxy. We have a web application firewall in a reverse proxy, appliance or a machine that is seated between the web client and the web server. The second is integrated in the all web server, which is more common in small companies. And the third option that's not so common, that's directly connected in the switch in port mirror, span, or HAP, that are other asynchronous names to the same, that basically get a copy of all the data that a network, that a port get. It's replied to another one when it's running the WAF system. Well, passive or reactive. Most WAF systems work both passive and reactive mode. In general, in the first days, they are running in passive mode to identify false positives, and in special when you are using some kind of automatic learning mode technology to detect this kind of problems and fix before put it in a production environment. In general, when it's running very well with .generate false positives, it starts to run in reactive mode. Well, a little back from Brazil. Here we have some famous guys from Brazil that probably all should be. The second thing that everybody asked me when I arrived here, hey, and the Brazilian Jiu-jitsu, what happened? It really works, blah, blah. That's the answer. Brazilian Jiu-jitsu really works. We can see Anderson Silva, Royce Grace, Rodrigo Minotauro, and many others. Well, here we have some tricks to defect WAF systems. Well, WAF systems leave several points that can be used that permit us to detect them. Example, cookies. We have example of Citrix NetScaler. Citrix NetScaler, in some cases, had a cookie in the application that allow us to detect it's running. As we can see, in the cookie field, we have NES, that is a synchron of NetScaler, underline AF, and the other names. This kind of cookie allow us to identify this kind of system. We can see in a real-life site. Here, this site is a real site on the internet using NetScaler from Citrix. We can see the cookies it added to the application and consequently allow us to detect the presence of the web application firewall. It's a common example of seeing or pointing that the web application firewalls add and should never happen since it should be stealth to the attackers. Header rewrite. Some WAF products allow rewriting of HTTP headers. The most common is the server field. What happened? Sometimes some web application firewalls, when you request a normal and valid URI or URL, they respond with a valid 200 code, and the server field is set for the name of web server or Apache, Internet Information Service, whatever. However, some products, when we request an invalid or hostile URL or URI, it simply remove the server field. So it's a thing that we can identify that there are some systems that can be a WAF that is protecting the site. And also some others WAF applications only override or allow the reader rewrite when we send some bad content. For example, requesting a hostility content. Below we have example. A valid and non-hostility request should return a 200 OK status code, and with the server, that is the real server content, Apache 2.2.9 running in Unix. Within the same server, we request a hostility request, for example, a well-known web exploit that this web application trigger. We can get the following response. The server was changed to Netscape Enterprise 4.0. So it's another problem in some web application products. They only apply the HTTP, the header rewrite in some circumstances that allow us to identify their presence too. Some WAF vendors return different HTTP response error codes in the same URL, valid one or not. If you insert a hostility parameter, for example, just to be more clear, since my English is far away to be good, suppose we had, not in this case, for example, a page, no is index.php ID equal 1, 2, 3. For example, it's a kind of a suppose valid request and is processed. If we put in the same request that always return the code 200, for example, it should be processed okay. If we just change the 1, 2, 3 to something like pipeline ID or ID that is hostility contents, in general, people trying to execute the operating system command, this can return for us a different HTTP response code. For example, 404 as if the page index.php doesn't exist, which is not true. So we can be sure that it's not the content of the web server and the application in the middle, like a web application firewall. Also, the same happen if you request parameters that doesn't exist. For example, no exist, and the same parameters, it will return, in general, errors 423, 500, and the other. So this kind of returns can help us to identify the web application firewalls. Here is a valid example that was used in one of the application firewalls we tested. A valid request with a hostility parameter that doesn't exist returned 501 status code method not implemented. For sure, it's not valid. And also we could note that the allow was changed because the allow option of this HTTP header in the normal request never returned the trace option. So there are a lot of small points that can be used to detect this kind of systems. Well, backing. Some WAF vendors provide a filter to close connection. You can use it to drop the connection, block users, and they also have the possibility to interact with firewalls, external firewalls. Well, ModSecurity is a common example. They have a feature called the drop action that immediately initiates a connection close action using a thin packet. Attackers can launch well-known attacks that mismatch the built-in rules from ModSecurity and analyze the back to the thin packets and try to identify the presence of a web application firewall possibility ModSecurity. This kind of filter is not available in older versions of ModSecurity. Some of these techniques we are using to identify web application firewalls can be used also to identify intrusion prevention systems that are available on the market. What more about Brazil? Well, backing. Tricks to fingerprint WAF systems. All WAF systems have a built-in group of rules in negative mode that are rules based in blacklist that we spoke on the start of the presentation. These rules are different in each product. These rules can be specific to a well-known vulnerability. For example, the old EES Unicode attack can be a generic rule for a well-known class of vulnerability like SQL injection, cross-site scripting, and the others. And in general, these rules are associated with an action like drop the request, redirect to another page, etc. Attackers can create a set of attacks that test for a range of vulnerabilities that most WAF system protects against or not. In this way, we are able to identify building rules of a product and consequently what product it is. What it means? We can generate a database of a big variant of web application attacks that some web application firewalls detect and the others not. Based in the detection or not detection, we can identify the software remote. For example, suppose we send a request with a HTTP method that is different from 1.0 or 1.1. For example, using 0.9. Some web application firewalls detect this and block the contents or return a different HTTP code or can redirect you to another page, etc. Request a content language in a method which is different from post. It's the same. It's not a valid request that all web application firewalls detect, but some detect. URI with recursive path, even invalid. We can request, for example, a URI accessing recursive paths, even that doesn't exist. Some web application firewalls will detect the recursive path using Unix notation or Windows notation. Also, it can be used to detect the difference between them. Request where cookie matches the CMD name that is also detected by default by some web application firewalls, by other not. Requests where the URI matches the string or the URI itself, USR, X11, R6, bin, Xterm. In general, we can create a really big database of this kind of checks and run against most web application firewalls, and we can detect based in what can detect and provide a different response for us or not, and in this way identify what web application firewall it is. More or less like we do probes in operation system. Basically, the idea is the same. The attacker can go deeper and create several mutations of the same attack using, for example, evasion methods. These evasion methods can make a well-known rule be bypassed or not, and this also can be really useful to identify more precisely systems. Sometimes identify different versions, a new version from an old version. Also, some tactics presented on the start, on the tricks to detect WAF systems in the first slides can be used and help to identify systems, like the example of Citrix NetScaler. These techniques can be used to generate a big database and, as we've spoken, to create tools to detect this kind of web application firewalls automatically. Well, generic evasion techniques. Today we have a wide range of techniques to evade EPS and some WAF systems. Most of these attacks works because we have bad normalization, for example, encoding, etc., and the canalization, that the implementation in the WAF does not work very well. Weak rules, the full weak rules built in the WAF systems. We can see a big number of products in the marketing that have pre-built rules that are really weak, and they allow a big number of possibilities of evasion. Evasion at network transport layer in some EPS and some WAF systems, depending when they are running. For example, if they are running in port mirroring. Well, here we have some examples of common generic evasion techniques. A very common generic evasion techniques to bypass some WAF systems is add SQL comments to parameters instead of space to try bypass WAF systems and some EPS systems. Also is put words in case sensitive and case insensitive to try defect some of these rules too. This too is very common. SQL query encoding is common. We use resources that the own database provide for us, like stored procedures, etc., that allows the attacker to encode and decode data, for example, to hexadecimal directly in the database. In this way, we can bypass some EPS and the WAF system in some cases. Double encoding, that basically is the same idea of the original encoding, but the SIGINT itself, for example, the percent is encoded too, so you add a double encoding. URL encoding, like for example, Unicode forward slash that was possible some time ago. Don't remember exactly how much. For example, in the tipping point EPS, using this kind of technique also applies to some EPS and some WAF systems. HTTP request smuggling, that basically is a technique that some attackers use to create a HTTP packet that will be parsed differently in the back-end web server and in the web application file, reverse proxy or whatever that is in the middle of the connection. IP packet fragmentation in some cases, depending on the topology, is possible. That basically use the question of fragmentation and the reassembly to bypass the same. Brazilian Carnival, that everyone always asks. Probability all of you know, and who don't know should go to Brazil, to the Carnival, and you appreciate boys, girls, everybody. Specific techniques to evade WAF systems. Similar as attackers can fingerprint WAF system as presented, they can use a technique to precisely identify which restriction of a rule applies to a specific class of vulnerability. What I mean? An attacker can insert a hostility SQL injection, for example, to a parameter, and is expected to be detected and the action taken. For example, a different HTTP error code be returned, a page redirection, etc. Or simply generate an error code or the normal page be displayed, depending on of the web application file. The big point is we can try a high number of different hostility queries and discover exactly what SQL query is blocked and which is not. What word, for example, select, from, where, exec, xp, underline, exec, and the others query are used. If we are able to detect these strings that are used by the web application file built-in rules, we can try to bypass them. Using try and error, it's possible to identify the combinations of these strings, which is allowed and which is not. Also, it's common we have rules that is based on combinations. For example, only select is not blacklisted, but if you use together select, from, and where together, it starts to be blacklisted. So based in this information, we can try to construct SQL injections in the case to bypass the web application file. Also, this can be used to deny. It can be used to detect how the rule was built. Let's get a real example. It not can be used only with SQL injection. It can be used with a lot of other attacks like cross-site scripting and the others. Real life. In a penetration test, we realized maybe 3 months ago, we had a client in Brazil, which is a bank, that we had made a penetration test before, and we got the access to the system. So they got the solution from Citrix NetScaler, and now we made the penetration test again. All we have to do to bypass the Citrix with the same problem was to identify what strings was blacklisted and what not, what combination was and what not, like in the previous slide. And then we identified that the same query we used in the last time to retrieve a lot of information from the bank, we could use just remolding the query without new words in the query, using some database query encoding and removing all the single quotes. And the Citrix NetScaler was bypassed. So a lot of the systems that people sell today that are WAF systems are really good, but we cannot trust in the built-in rules. They help, but they are really far away to be perfect. In general, what are big pitfalls that web application firewall have problems to detect? Cross-site scripting. Cross-site scripting is really hard to effectively detect and block. It's extremely mutable and consequently very hard to detect, in special when we are dealing with outbound traffic. The outbound traffic have rules that in general can't be so enforced like inbound. For example, in general, we get a lot of news from third sites and the older contents. These older sites or older contents can be hacked and used as a source to infect your site in the outbound connection, even if using a web application firewall. File uploads. Many web application firewalls do a great job in file uploads. However, we have some tricks that's really hard to bypass. For example, when you insert web shells inside the images and call it, for example, via local file inclusions, via comments in JPEG and the others. Also, remote command execution based in server response is very hard to detect. Some web application firewalls in the last year, maybe, tried to detect some remote code execution, like, for example, the return that when we type in a Unix machine, the command ID, the command uname, ps, ls, they have a kind of standard format, and there are rules that try to identify this standard, to identify it in the outbound traffic. It's a good idea, at least in the start, since it could detect a lot of people that had broke into the web server. But if the attacker had the access, he is able to execute command on the web server, it's not possible to really detect, since he can use a lot of tools that the OWL encode provide in the Linux, or even the OWL shell, like Bash. You can turn it in Xcode, you can do shift right, shift left, and a lot of encoding in the output that you will not trigger the rule. So this kind of detection is not always useful and can be easily bypassed. Other problems that is probably one of the most hard to detect is logical and design flaws, which is extremely hard by the nature of the problem. Basically, suppose you have a bank, and this bank have a place where you can check how much money you have in your account. It's common that this data, like agency, account number, is passed as parameter. If there is not a stronger check in the application to grant that your sessions, your cookies, is related with this data that's passed this parameter, attackers can manipulate this kind of data and access information from other users. This kind of problem is very hard to web application firewalls detect and block, and the holders in the same idea. Well, our time is finishing. We had 10 minutes. It's over. I would like to thank you, all of you. Also, the site Hackaholic is looking for new members. We have a private forum where we share a lot of stuff. If someone is interested, we are looking for new members. Thank thank you all, and sorry for the problems in the laptop and the delay to start.